Hi students, today we are going to discuss exercise 6.7 remaining problems. Third question, find the parametric form of vector equation and Cartesian equations of the plane passing through the points 2, 2, 1, 1, minus 2, 3 and parallel to the straight line passing through the points 2, 1, minus 3 and minus 1, 5, minus 8. Find the parametric form of vector equation and Cartesian equation. The plane passing through given 2 points. Passing through 2 points and parallel to the straight line passing through the 2 points. Already given 2 points. Already given 2 points and parallel is this one is the parallel. Now find the parallel vector. Now find the parallel vector. Already given 2 point and 1 parallel. 2 point, 1 parallel vector and a Cartesian equation of the plane. Now fine. Already you know the formula. Given 2 points. The parametric form of vector equation is R vector equal to A vector plus S of B minus A plus T of U. A and B are 2 points. That is a parametric form. Cartesian form is determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1. L, M, N, where L, M, N are parallel, equal to 0 is a Cartesian form of a plane equation. What is given? Given the point, passing through the points, given 2 points. First now write in a vector. Given the points, A vector equal to 2i vector plus 2j vector plus k vector. 2i vector plus 2j vector plus k vector. And B vector equal to B vector is I vector minus 2j vector plus 3k vector is the second point. Now find the parallel and parallel to the straight line passing through the given 2 points. Now find the parallel. Already a straight line formula, a straight line is given 2 points. Straight line formula given 2 points is R vector equal to A vector plus S of B minus A, where B minus A is the direction. That is the point is A and B are 2 points. Now find the direction only. Direction is B minus A. B minus A is the direction. So given the U vector equal to this vector is B minus A. The point is B. The point is A. B minus A is the parallel U vector. Now subtract the value. Subtract the points. Minus 1, minus 2, minus 3i vector. Minus 3i vector. 5 minus 1. 5 minus 1 is 4 plus 4j vector. So minus 8 minus half minus plus. Minus 8 plus 3 minus 5k vector is a parallel. That is a parallel vector. Or you write in here R vector equal to A vector plus S of B minus A is a equation of a straight line. Therefore the equation of straight line joining the 2 points formula. Here A vector is this one. 2i vector plus j vector minus 3k vector, that is a point A, plus S of B minus A, that is a B minus A is the point, minus 1 minus 2 minus 3i vector. Next one 5 minus 1 plus 4j vector. Next one minus 8 minus half minus plus 5k vector. That is the point is R vector equal to A vector plus S of, that is the direction. We want the direction, that is the direction is a parallel. That is the direction is equal to here U vector. That is U vector equal to minus 3i vector plus 4j vector minus 5k, that is a minus 5k vector. Minus 5k vector, that is a parallel vector. Given 2.1 parallel, find the parametric form of vector equation. That is the parametric form of vector equation. Parametric form of vector equation. R vector equal to A vector plus S of B vector minus A vector plus T of U vector. R vector equal to A vector plus S of B minus A plus T of U vector. Now substitute in the points. Here A vector is 2i vector plus 2j vector plus k vector, that is A, plus S of B minus A. Here the point B minus A, this one B minus A. b minus a is 1 minus 2 minus I vector. 1 minus 2 minus I vector. Next one minus 2 minus minus 2. Minus 2 minus 2 minus 4j vector. Minus 4j vector. Next one 3 minus 1. 3 minus 1 is 2 plus 2k vector. That is S of b minus c plus T of u vector. Where u vector is the parallel. Minus 3i vector minus 3i plus 4j vector plus 4j vector minus 5k vector. That is a parametric form of vector equation. Next, find the Cartesian equation of the plane. Next, Cartesian form. Cartesian form of vector equation. Given 2 points and 1 parallel, already the points x1, y1, z1 equal to the point x1, y1, z1 equal to 2, 2, 1. That is one of the point. And x2, y2, z2 equal to the second point is 1, minus 2, 3 minus 2, 1, minus 2, 3 the point 2. And L, M, N equal to, that is a parallel is, find the parallel is minus 3, 4, minus 5, that is a parallel. Now write in a Cartesian form is, now write in determinant form x minus x1, y minus y1, z minus z1. So on x2 minus x1, y2 minus y1, z2 minus z1. The parallel L, M, N equal to 0. Equal to 0. Now substitute the points x minus x1, x minus x1, here the point x1 is 2, x minus 2, x1, y minus y1, y minus 2, and z minus 1, that is the point z1 is 1. Next one x2 minus x1, x2 minus x1 is 1 minus 2, 1 minus 2 is minus 1. Next one minus 2 minus 2 minus 4, 3 minus 1, 2. y2 z2 minus z1 is 3 minus 1 is 2. Next write in L, M, N is minus 3, 4, minus 5 equal to 0. Now expanding the determinant, x minus 2 into getting the elements, column and row are eliminated, getting the minor matrix, this one, minus and minus plus 4, 5, 20. 4 5s are 20, formula is minus 4 2s are 8. Next one, taking the element y minus 2 into column and row are eliminated, getting the minor matrix, this one, minus into minus plus 1 into 5s are 5. Next one, formula is minus 3 into 2, minus 3 into 2, minus 6, already formula is minus into minus plus 3 2s are 6, plus taking the element z plus 1, z minus 1 into column and row are eliminated, getting the minor matrix, minus 1 into 4, minus 4. Next minus into minus plus, formula is minus 3 4s are 12 equal to 0. Getting the value. That is implies x minus 2 into 20 minus 8. 20 minus 8 is 12. Is 12 minus y minus 2 into 5 plus 6. 5 plus 6 is 11 plus z minus 1 into minus 4 minus 12 is minus 16 equal to 0. Minus 16 equal to 0. Now multiply 12, that is implies 12 into x is 12x minus 24 minus 12 into 2 minus 24. Next one minus y into 11 minus 11y minus 11y. Next one minus into minus plus 11 into 2 is 22 plus 22. Next one plus into minus 16 into z is 16z. Next one plus into minus into minus plus 16 into 1 is 16 plus 16 equal to 0. That is implies, now arrange the xy. Z. 12x minus 11y minus 16z. 12x minus 11y minus 16z. Next constant terms. Constant terms are to minus 24 plus 22. Minus 24 plus 22 is minus 2. Minus 2 plus 16. 16 minus 2. 16 minus 2 is plus 14 equal to 0. That is 12x minus 11y minus 16z plus 14 equal to 0 is a Cartesian equation of the plane. Next one, fourth problem. Fourth one, find the vector and the Cartesian equation of the plane passing through the point 1 comma minus 2 comma 4 and perpendicular to the plane. Perpendicular to the plane x plus 2y minus 3z equal to 11 and parallel to the line x plus 7 by 3 equal y plus 3 by minus 1 equal to z by 1. Find the vector and the Cartesian equation of the plane passing through one point. Passing through the point is 1 comma minus 2 comma 4. Given one point and perpendicular to the plane and parallel to the line. That is perpendicular to the plane means perpendicular to the line is given the x plus 2y minus 3z equal to 11 is the equation of plane. Now write in a vector form is r vector dot I vector plus 2j vector minus 3k vector equal to p. That is equal to 11. That is r vector dot n vector is I vector plus 2j vector minus 3k vector is a parallel vector. That is a direction. That is this one is the perpendicular to the plane is that is the parallel vector is I vector plus 2j vector minus 3k vector is a parallel. Given one point, that is one parallel and parallel to the line. Parallel to the line, that is the equation of the line in Cartesian form. Already you know Cartesian form is numerator is the points x minus x1, y minus y1, z minus z1, that is a point. X minus x1 by L or B1, B2, B3, B1, B2, B3 be the direction. The direction is the parallel. Direction is a parallel. That is the parallel vector is 3a vector minus j vector plus k vector is the parallel. One parallel. Already one point, this one is parallel, this one is parallel. So two parallel. Now find the vector and the Cartesian equation, the plane passing through one point and two parallel. One point and two parallel. Already you know find equation of a straight line, equation of a plane passing through one point and two parallel. That is a vector form is or parametric form of vector equation. R vector equal to a vector plus s of u vector plus t of v vector, where u and v are two parallels. Here a vector is one of the point. And the Cartesian form is determinant of x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0 is a Cartesian form of the equation of the plane. Now, given the point, first one, given the point a vector equal to given the point a vector equal to I vector minus 2j vector plus 4k vector given the one point. And the perpendicular to the plane is, that is the perpendicular to the plane, that is the plane equation is x plus 2y minus 3z equal to 11 is the equation of plane. Write in a vector form is r vector dot I vector plus 2j vector minus 3k vector equal to 11. Equal to 11, that is a vector form. Let r vector equal to xi plus yj plus zk to get the equation of the plane. R vector dot I vector plus 2j minus 3k vector is the n vector. It is a normal vector. Where normal vector means a perpendicular. So the perpendicular is also a parallel vector. Is a parallel vector. This vector I vector plus 2j vector minus 3k vector is a parallel vector. Now write in u vector equal to I vector plus 2j vector minus 3k vector is the one of the parallel. And parallel to the line, we want take the parallel only, that is the parallel is this one, 3 minus 1 be the parallel. 7, 3, that is x minus x1 minus 7 minus 3, 0 be the point. We want the parallel only, that is the parallel is 3 minus 1 is the parallel. It is a parallel v vector equal to 3i vector minus j vector plus k vector be the parallel. 3 minus 1, write in a vector, 3i vector minus j vector plus k vector be the parallel. given 1 point and 2 parallel, given 1 point and 2 parallel equation of a plane in parametric form of vector equation, parametric form of vector equation, that is r vector equal a vector plus su vector plus tv vector. R vector equal to a vector plus su vector plus tv. 1 point or 2 parallel. Now substituting the vectors. A vector is I vector minus 2j vector plus 4k vector plus s of u vector is here u vector I vector plus 2j vector I vector plus 2j minus 3k is u vector plus t of v vector is t of v vector 3i vector minus j vector 3i minus j plus k vector. That is a parametric form of vector equation. Next find Cartesian equation of the plane. Cartesian equation of the plane. Cartesian form. Given the one of the point is x1, y1, z1. Given one point is 1, minus 2, 4 be the one of the points, and the parallel are L1, M1, N1 equal to L1, M1, N1 is 1, 2, minus 3. 1, 2, minus 3, and L2, M2, N2 is L2, M2, N2 equal to L2, M2, 3 minus 1 plus 1. 1 point and 2 parallel. The point is x1, y1, z1 be the one of the points. L1, M1, N1 be the first one parallel, and second parallel L2, M2, N2 equal to 3 minus 1, 1. Now write in a Cartesian form. There is a determinant of x minus x1, y minus y1, z minus z1, L1, M1, N1, and L2, M2, N2 equal to 0. Now expanding the determinant, that is implies x now substitute the value, x minus x1. Here x1 value 1, x minus 1, x1, y minus y1. y1 value minus 2, already pharma minus or minus plus, y plus 2, x1 z minus z1, z1 value 4, z minus 4. X1 substitute L1, M1, N1 value 1, 2, minus 3, and L2, M2, N2 value 3 minus 1 plus 1. 3 minus 1 plus 1 equal to 0. Now expanding the determinant, that is implies x minus 1 into x minus 1, column under row are eliminated, getting the minor matrix 2, 1, 2, formula minus and minus plus 1 into 3, 3, that is minus 3. Next one, minus of y plus 2 into column under row are eliminated, getting the minor matrix 1 ones are 1. Next one, 3 into minus 3, minus 9, formula is minus plus 9. Next one, plus z minus 4 into column under row are eliminated, getting the minor matrix 1 into minus 1, minus 1. Next 3 2s are 6, formula minus 6 equal to 0. That is implies x minus 1 into 2 minus 3 minus 1. 2 minus 3 minus 1. Minus of y plus 2 into 1 plus 9. 1 plus 9 is 10. Plus z minus 4 into minus 1 minus 6 is minus 7. Minus 7 equal to 0. Now multiply v. This implies minus 1 into x is minus x. Next minus and minus plus 1. Next one, 10 into minus y minus 10y. Plus and minus is minus 2 into 10 minus 20. Next one, minus 7 into plus z. Plus and minus 7 into z is 7z. Sorry, minus 7z. Next one, minus and minus plus 7 fours are 28 plus 28 equal to 0. 28 equal to 0. That is implies minus x minus 10y minus 7z. Next one, constant term 20 minus 20 plus 28, 28 minus 20 plus 8 plus 8 plus 1 plus 9 equal to 0. That is implies minus x minus 10y minus 7z plus 9 equal to 0. Both sides multiply by minus x plus 10y plus 7z minus 9 equal to 0 is a Cartesian equation of a plane. Next problem. The fifth one. Find the vector and the Cartesian equation of the plane containing the line r vector equal to I vector minus j vector plus 3k vector plus t of 2i vector minus j vector plus 4k vector and perpendicular to plane r vector dot I vector plus 2j vector plus k vector equal to 8. Find the vector and the Cartesian of the plane containing the line r vector equal to I vector minus j plus 3k plus t of 2i minus j plus 4k. Containing means one point and one parallel. Taking one point and one parallel. That is the equation of the line is where line is point and one parallel. One point and one parallel, that is called a line. It is a line equation. Now I am taking the containing the line means taking one point and one parallel. One point, one parallel. And perpendicular to the plane r vector dot I vector plus 2j plus k equal to 8. Perpendicular is also a parallel. It is a parallel vector. That is a parallel vector is I vector plus 2j plus k vector is a parallel vector. Already given 1 point, this one parallel, 1 point and 2 parallel. 1 point, 2 parallel. Find the vector and the Cartesian of the plane passing through 1 point and 2 parallel. Already you know the formula. Parametric form is r vector equal to a vector plus s of u vector plus t of v vector. 1 point, 2 parallel. That is a Cartesian form is x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0 is a Cartesian form of the plane equation. Given the plane, containing the line means point, 1 point and 1 parallel. Write in a vector equal to this 1 point, I vector minus j vector plus 3k vector is one of the point. This one is a parallel. This u vector equal to the parallel vector u vector equal to 2i vector minus j vector plus 4k vector is one of the parallel. And perpendicular to the plane, that is the equation of the plane in a vector form. R vector dot n vector equal to some p is the distance. Now I am taking v vector, that is a v vector is a parallel. It is a parallel. Also perpendicular is a parallel vector. V vector equal to I vector plus 2 j vector plus k vector be the parallel vector. Given 1 point and 2 parallel. 1 point, 2 parallel. You know the formula, parametric form of is a parametric form of vector equation. Parametric form of vector equation is r vector equal to a vector plus su vector plus tv vector. R vector equal to a vector plus su vector plus tv vector. Now write in a vector is I vector minus j vector plus 3k vector plus s of u vector. Here u vector is 2i vector minus j vector plus 4k vector plus t of v vector is I vector plus 2j vector plus k vector plus k vector is a parametric form of vector equation. Next to find Cartesian equation of the plane. This is a Cartesian form. Here 1.2 parallel. Here the point x1, y1, z1 equal to, the point is 1, minus 1, 3. L1 M1 N1 equal to L1 M1 N1, the parallel 2 minus 1 4, 2 comma minus 1 comma 4, and L2 M2 N2, L2 M2 N2 equal, that is the second parallel 1 2 1, 1 comma 2 comma 1, that is a 1 point and 2 parallel. Now write in a Cartesian form, determinant of x minus x1, y minus y1, z minus z1, L1 M1 N1, L2 M2 N2 equal to 0. This is a Cartesian form. Now substitute the value x minus x1, here the point x1, x minus 1, next one y minus 1 is, formula is minus, minus or minus plus, y plus 1, next one z minus z1 is 3, z minus 3, L1 M1 N1 is 2 minus 1 4, 2 minus 1 4, L2 M2 N2 is 1 2 1 equal to 0. That is the determinant form. Now expanding the determinant, getting the equation of plane, x minus 1 into minus 1 into 1 is minus 1. Next formula is minus 2 4s are 8. Next one minus of y plus 1 into minus of y plus 1 into 2 1s are 2, 2 2 2 1 2, formula minus 1 into 4 4, minus 4 plus z minus 3, taking the element z minus 3 into column under row element, getting the minor matrix 2 2s are 4, 2 2s are 4, next one 1 into minus 1, formula is minus plus 1 equal to 0. This implies x minus 1 into minus 8 minus 1 minus 9, minus 1 into minus 8 minus 9, multiply by minus 9 into x, minus 9x, minus into minus plus 1 into 9, 9. Next one 2 minus 4, 2 minus 4 is minus 2, multiply by minus 2, minus into minus plus 2y. Next one minus into plus is minus, minus 1 into minus 2 plus 2, plus 2. Next one 1 plus 4 is 5, multiply by 5, 5 into z is 5z, 5 into z is 5z. Next one minus 3 into 5 minus 15, minus 15 equal to 0. That is implies minus 9x plus 2y plus 5z plus 5z. Next constant term 9 plus 2 11, 11 minus 15, 11 minus 15 minus 4 equal to 0. This implies this equation is multiplied by minus this 9x minus 2y minus 5z plus 4 equal to 0 is a Cartesian form of the vector equation. Next, seventh problem. Find the non-parametric form of vector equation and the Cartesian equations of the plane r vector equal to 6i vector minus j vector plus k vector plus s of minus I vector plus 2j vector plus k vector plus t of minus 5i vector minus 4j vector minus 5k vector. Find the non-parametric form of vector equation and the Cartesian equation of the plane. Here r vector equal to a vector plus s of u vector plus t of v vector. R vector equal to a vector plus s of u plus t of v vector. Already you know the formula. R vector equal to a vector plus s of u plus t of v vector is parametric form of vector equation given one point and two parallel. One point and two parallel, that is a parametric form of vector equation. Here the point is a, that is the one of the point. The point is u vector, that is a parallel. U vector equal minus I plus 2j plus k, that is a u. The point t of v, that is a parallel v vector, given one point and two parallel. 1 point, 2 parallel. Now find the non-parametric form of vector equation and Cartesian equation of the plane. So given the point a vector equal to, the point a vector equal 6i vector minus j vector plus k vector, that is the one of the point, and two parallel. First one write in u vector equal minus I vector plus 2j vector plus k vector, one of the parallel, and v vector equal to v vector minus 5I vector minus 4j vector minus 5k vector, that is the second parallel. 1 point and 2 parallel. Now find the non-parametric form of vector equation. Find the non-parametric form of vector equation. This is a non-parametric form. Ready? You know the formula, non-parametric form of vector equation: r vector minus a vector dot u vector cross v vector equal to 0. R vector minus a vector dot u vector cross v vector equal to 0 is a non-parametric form of vector equation. First, now find u vector cross v vector. U vector cross v vector. U vector cross v vector equal vector product of two vectors. Vector product of two vectors by using determinant form. It is a determinant of I vector, j vector, k vector. The component of u is, that is a u, minus 1, 2, 1. And the component of v is, that is a v vector, minus 5, minus 4, minus 5. Now expanding the determinant I vector into 2 into minus 5 minus 10. 2 into minus 5 minus 10. Next one, formula minus 4 into 1 minus 4, formula is minus into minus plus 4. Next one, minus j vector into, getting the minor matrix, minus 1 1 minus 5 minus 5. Minus into minus plus, 5 ones are 5. Next one, formula minus 5 into 1 minus 5, formula minus plus 5. Plus, taking the element k vector into this one. Taking the element k, column under row element, getting the minor matrix, minus 1 into minus 4 plus 4. 4. Formula minus of minus plus, 5 2s are 10. This is 10. These are 10. This is equal minus 10 plus 4. Minus 10 plus 4 is minus 6. Minus 6 I vector. Minus 6 I vector. 5 plus 5 10 plus, minus into plus minus 10 j vector. Next one, 10 plus 4 14 plus 14 k vector. That is u vector cross v vector. This is a u vector cross v vector. U vector cross v vector substitute in the non-parametric form of vector equation. Now substitute non-parametric form of vector equation, r vector minus, here a vector is 6i vector minus j vector plus k vector dot u vector cross v vector. U vector cross v vector is minus 6i vector minus 10 j vector plus 14 k vector equal to 0 is a non-parametric form of, vector equation. And next find Cartesian equation of the plane. Cartesian equation is a Cartesian equation of the plane, Cartesian form. Cartesian form is given 1 point 2 parallel, that is the point is x1, y1, z1 equal to one other point is 6 minus 1, 1, and the point L1, M1, N1 equal to point L1, that is the point L1, M1, minus 1, 2, 1, minus 1, 2, 1, L2, M2, N2, that is L2, M2, N2 equal this point minus 5, minus 4, minus 5, minus 5, minus 4, minus 5. Now substitute in Cartesian form, determinant of x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0. Now substitute in x1, y1, z1, L1, M1, N1, L2, M2, N2, the points. This implies x minus x1, x minus 6, y minus y1. Here y1 is minus 1, formula minus or minus plus. And z minus 1 by z minus 1 and write in L1, M1, N1 is minus 1, 2, 1. L2, M2, N2 is minus 5, minus 4 and minus 5 equal to 0. Now expanding the determinant, this implies x minus 6 into 2 into minus 5 minus 10. Next one, formula is minus 4 into 1, minus 4 into 1, minus 4 formula is minus half minus plus 4, minus half y plus 1 into minus half y plus 1 into minus plus 5. Next one formula is minus 5 into 1 minus 5, formula is minus half minus plus 5. Next one plus z minus 1 into minus 4 into minus 1 plus 4. Next one minus 5 into 2 minus 10, formula minus half minus plus 5 2s are 10 plus 10 equal to 0. This implies x minus 6 into minus 10 plus 4 minus 6 multiply by, or writing one step, x minus 6 into minus 6 minus of y plus 1 into 10 plus z minus 1 into 14 equal to 0. 14 equal to 0. Now multiply minus 6 minus 6x minus into minus plus 6 are 36. Next one minus y into 10 minus 10y. Next one minus into plus minus 1 into 10 is minus 10 Next one 14 into z, 14 z minus 1 into 14 minus 14 equal to 0. Now write in the x. First one write in 6x minus 6x and minus 10y plus 14z. Next constant minus 10 minus 14 minus 24 plus 36 plus 12 equal to 0. That is implies multiply by or divide by minus 2. This equation is divide by minus 2. That is implies 3x, 3 2s are 6, 3x plus 5 2s are 10, 5y minus divide by minus 2 minus 7 2s are 14, 7z minus 12 by minus 2, that is minus 6 equal to 0. This 3x plus 5y minus 7z minus 6 equal to 0 is a Cartesian equation of the plane. Okay students, exercise 6.7 problems is over. You work out the example problems, try yourself.